Hi, I am Aggie again from fakopp, and this is ArborSonic Academy 6th Biomechanics tab. This tab lets you compare the load-bearing capacity and the estimated loads occurring on the tree. These loads include the wind, self-load, and the lean if the trunk is leaning. Please be aware of that the software knows only the data which is inside of it. So I mean, it can estimate only the layers which were measured. It has no information about the whole tree or about any other layers which were not measured. Keep in mind that ArborSonic software is a great tool for arborists, tree examiners, tree assessors, but the expert, him or herself, should choose the weakest layer, the layers where they should measure. The software helps you with highlighting the weakest layer at the end, but it is just one layer from the measured one, okay? So I hope it's clear for everybody right now. So if you look around this tab, well, there are many things you can change or you can set, but if you need just a quick help in any time, you can go over these question marks and read the explanation in these bubbles. I will start with an example showing you the evaluation step by step with explanations. So it might be a little long, about a half an hour, but in this case I will explain only the functions, and later in ArborSonic Academy there will be a case study episode. So in that I will show you that the biomechanics evaluation takes only a minute if you are familiar with this step. I will start with showing you what to do if you have a photo of the tree, and after it I will tell you about the settings in the left side. So now I will go to the other side to let you see everything here. Okay, here am I. And one more remark before we start, that if you don't have a photo of the tree, it's not a problem if you have at least some parameter of the crown, maybe the height, the width, or the area itself. But I will show you those functions later. So let's start here on the right side of the software window. So here we are in image editor, which has two parts. The image container, which is the same image container where you could export images from the sensor geometry tab or from tomograms tab, and which is right here on the following tab. I will speak about it in another episode. And the image editor has another part, the editor part itself. So here in the top, you can see all the images you have exported before, and you can use the same functions you can use in the image container. So you can import an image into the container, you can export an image to a file, to a location on your computer, you can rename or delete an image. On the left side, with the slide and these magnifiers, you can change the sizes of the images. And if you want to have more space in the editor, you can collapse the image container part to have a bigger view. If you take a photo of the tree which you are examining, well, first of all, you have to be at least as far from the tree as the height of it. So it is the minimum distance, okay? Minimum. So please go as far as the height of the tree, because if you don't go, you will have images like this, which are very nice image, but you see that so we have two problems, or three, that there is no, I cannot see the bottom of the tree, the trunks, I cannot see the ground, I cannot mark the top of the crown, and the scale is changing. So what is 1 meter here, it's not the same 1 meter there. For decreasing perspective distortions, you have to go far from the tree, or farther, or at least as far as the height of it. Okay, so let's see another photo. Here in this case I have this tree here, and maybe I remember that the crown finishes here somewhere because it was cut, but I cannot see it in the photo, and the real problem is that this is outside the area of the photo. So when I try to mark the crown area, I will show this function later, I cannot mark area outside the photo, just on the photo. This image is just not usable, not useful for marking the crown area. So I went a little more far, and here I can mark the crown. Even if the crown itself is hidden, there should be enough space on the photo where you can mark it. So you see here is another tree in the front, but I remember that my examine tree crown is just behind it, so I will mark maybe like this. There should be enough space in the photo to be able to mark. So if my photo would end here, that would be useless again. And well, of course, if you take a photo above the trees, well, these are trees in a park, and this photograph was taken from maybe the 20th floor of a building, but I cannot really mark the crown area here, so please avoid these mistakes. And well, this is the ideal clear picture of the photo, but sometimes it cannot be taken. Just please always remember that. Go at least as far as the tree height, the bottom of the trunk, and the top of the tree, well, visible or at least markable on your photo. Now I will import or image of the tree, and when I import a photo, it will be the last image. Let's see these buttons here. The first three buttons are the functions for marking the crown area, a reference height, and for the leaning of the trunk. Let's see the first one. I place dots around following the shape of the crown. I can place as many dots as I like, so I can go into details, or I can just make it an estimation. And at the end, I don't have to go back to the first dot, which is squared, which has a squared mark, but I can let the software connect them, so I just have to finish somewhere close to the first dot. If I don't like these positions, I can go over them with the mouse, and when I see this finger pointing, I can grab and move that dot. To finish, I just turn off this function and let the software mark the area with a curved outline. The dots are movable later, so I can turn on this function again, and if I like, I can move the dots. But What I cannot do is to add more dots. So if I would like to have a more detailed area selection, I should have to import the photo again and start the selection again. Okay, here I have the area, but we don't know the size of it yet because the software doesn't know how long is a meter or anything else. So we need a reference height. The best is to use the height of the tree. So if you can, just please measure it. So I place one square marker at the bottom of the tree and one at the top if I know the height of the tree, but I can do it with any other objects which height is known. So, and I can move these dots as well, so I could use this building, a car, or there is a people standing here. So any object with a known height is useful, can be used in this situation, but the best is to use the height of the tree. And well, as you see, I have to come here to the question marks, and when I click here, a new window popped up, and here I have to enter the height of the well-known object. Okay, when I'm ready with that, I turn off this function and let the software calculate the area. When marking the crown area, it's important to mark the crown area only. The trunk's area, well, it is exposed to the wind as well, and it's important, but it will be calculated from the geometry data and from the next function, which is this protractor icon, and this will show you the leaning of the trunk. So this is one more information you have to give. So first I place a dot at the ground where the tree trunk starts. Here it will be a squared marking, and I will place another marking in the direction of the trunk and one more in the horizontal direction. Well, I can move all of these three markings if I'm not content with the situation, and this is how the software will know if the trunk is leaning or not. So this is one function of these lines, while the other function is then to define where the tree starts. So this is how the software will know the size of the trunk, and well, I mean the height of the trunk, and the width of the trunk is from the layers measured, the layers which were defined in sensor geometry. Okay, now I can turn it off and I have the data. But we still have some functions here on the right side. So I can save an image, export an image to the image container from where I can export it to a location on my computer. And this image, so this icon is for saving this image right as I see. So it will include these markings and these numbers as well. Next possibility is to magnify your image. So maybe you want to have a more detailed selection somewhere, or just be sure, so you can zoom into the image and then we can return to the original size. With this eye icon, I can turn on and off the markings. So I turn off the area marking, I turn off the reference height marking, and I can turn off, of course, the leaning marking. This eye icon is only for the picture, so the data didn't change, as you can see here. So I can give these back. It is useful if you maybe want to have a picture with only the height. So then you can have this image and export it to the image container. The last icon is a leaf here, and it lets you recolor the image, because it is useful in some cases. Sometimes it helps to see, it makes the crown area more visible. So that's why we have two possibilities for recoloring. Okay, these were the functions related to the image. So I will continue on the left side. So I move back to the other side of the video. So here I am on the other side, not hiding any interesting icons. So the panel on the left side is for wind and load calculations. Regarding wind load calculations, the software offers you two different models, the so-called uniform and the European standard EN 1991. I will start with this one. In this case, if we have chosen this wind model, the next step is to choose a terrain category. But what is this for? So, this model divides the crown area into 6 or less different slices, different parts, and it calculates the wind velocity and, well, the moment which is caused by the wind for that slice, and at the end they are summarized up. Well, in this case, just to try to explain how it works, you get the standard and you will find the base velocity for your area, and well, you will find the dry air temperature for your area as well. Well, for some help, you can check your manual as well. If you are just at the beginning of calculating the wind load by the European standard. So these numbers are just in the standard for your area, and that should be set here. But the wind velocity is not 26 meter per second in all the height and in all the areas. So that's why you have to choose a terrain area. And if you choose city, it means that there are high surroundings, high buildings around the tree in this part of the city, or even in the village. So it means it's a city-like area where you have high buildings, which means that not the entire wind will come to your tree, just a part of it. So the wind load is less. And as you as you check these categories, which means that there are lower buildings, and in agriculture there are less buildings, or lower buildings again, and maybe a few other trees. Lakeside and seashore are the places where there are just very low or very few objects in the surrounding of the tree, and on the seashore the tree is exposed to the entire wind load. Okay, so that's why, and it is very, very important. So please, if you are not familiar with this topic, check at least the manual. We have some figures and maps, but it's the best if you can go to the regional office of standards and get a map of your country, your area. So it is very important to select the correct terrain category, because you see, if this tree stands in a city, it has low risk. I will explain it later what it means, but if I change it maybe to an agricultural area, now we have moderate risk. And if this tree was standing on a seashore, it would have high risk in this condition. So maybe we can reduce the crown area. We can do this simulation, like with moving these dots. What I wanted to tell you is that you must choose the correct terrain category, and you should use the values which are in the standard for your area, because sometimes it's even less, this base wind velocity, but sometimes it's higher, so, and it's not the same. So if I change it, you see the safety is changing. Maybe not the category low risk, but this value, the number. Okay, let's move on to the next one. This is dry air temperature. I have already mentioned that it is also included in the standard, but what it stands for? So dry air temperature is just a term of physics, because physicists can measure temperature with wet thermometer and dry non-wet thermometers as well. So this is just the normal meaning, the daily meaning of temperature, just in a physics term. Even if the software lets you to set a number below zero, this refers to the air temperature, which affects air density, which affects the wind load. So if we have lower temperature, the density is higher, it's more dense, so there will be more wind load. But this does not refer to the wood condition, to the conditions of the trunk, the wood material, because so if the water freezes, the wood material's condition can change significantly. Don't be misled by this area, this field here. The software cannot estimate if the trunk will be still safe if the water is frozen inside or not. Continuing with crown section. Here we have crown models. The drawn one is that what you see here when I had a photo and I draw the crown area, the reference height, and the lean. I can turn the functions on, and now I can draw it again or move the dots, but I can turn this function off only here on the right side. And I can do similarly with the reference height. In this case, in the drawn model, all the values are calculated by the software from the photo and from the reference height. We can also switch the model to the calculator one, and in this case there will be a calculator icon here. Clicking onto this pops up a new window, and here I can set the crown width and the crown height, and well, I have to have an estimation of the crown shape, an ellipse, a triangle, or it can be rectangular. And these values here in the second column refers to a multiplying factor. So this calculator will calculate the crown area very simple. It will be width times height times shape factor. So if it's a triangle, like it's half, in case of ellipse, it's p divided by 4. But in this case, I still have to set one more value, which is 1 by default. This is the bottom height of the crown, so this where the trunk reaches the crown, and I think it was about 7 meters when we got this data from the photo. Well, it says extreme risk. What's the problem here is the leaning of the trunk. So when it is not from the photo, we have to set it, and this is the next function. So in this case, the lean is measured from the horizontal direction. So a vertical trunk is 90 degrees. And if there is a little lean, but you can change it. If I switch back to the drone crown model, the tilt angle can be drawn, so it means that it's coming from this image. So this is the degree between these two yellow lines. Or I can just uncheck this checkbox, and in that case, I can give it manually. Well, the program already needs to know the direction of the lean, and of course the software does not have any information about directions on this image, so this direction should be set, and we can choose from the main direction like north or southeast in this menu, or we can select manual, which pops up a window, and here we can set the direction of the lean with a 1 degree accuracy, so I can set 32 degrees if I like. It will affect the load because not all the trunks are circular and not all the decays are circular, and if we have a wind coming from one direction, and we have self-load from the lean, this direction can be very important. It can change if the tree will be still safe or having a high risk. So please don't forget about this. The next part do not have any input fields. They are just for presenting the information. So before finishing here, I will go back to the top and change the wind model to the uniform. Uniform model simplifies the wind load into one force acting at the crown center. This force includes the crown area as well, so its magnitude is bigger, is greater if the crown is bigger. So so even if it seems to be a very simplified model, it still can be very useful, but it works in a different way. So in the European standard, we had different slices, different heights. In this case, we have just one force at the center of the crown. Okay, in this case, we have less information here, and this is the wind velocity. This is the actual highest expected wind velocity at that area where the tree stands. Usually we use 120 km per hour, which is 33 meter per second, but if in that area where the street stands, maybe it's a mountain area or on the seashore, the expected highest wind can be higher, maybe 150 km per hour, which is about 22 meter per second. So you always have to set here the highest expected wind. Okay, so this is for this wind. In the next part, at crown, it is very similar to the crown part using the European standard wind model, But in this case, we have one more possibility. So we have drone is the same, calculator is the same, and now we have manual, which means that if you have all the information, like the area of the crown, the height of the top of it, the height of the center of the crown, and the height of the bottom of it, then we can just set it here, and the software will calculate from these data. The trunk part is the same. We can set here the degree of the lean, and of course we can get it from the photo if we have selected the drawn model at crown part. Let's move on to the last, the representing part of the left panel. At tree section, we have the wind load. These are coming from the wind and the model and the crown, which was set here in these parts. Then we have center height. In this case, if we use the manual crown model, it was set here to be the center, but in other cases it is calculated by the program. And we have two more values here. Both of them are coming from tables, and both of them depend on the species as well. So it is very important to select the right species at the beginning of the measurement at tree tab. Okay, drag factor is the aerodynamic drag. It means that how the tree is resistant to wind, how it is easy for the wind to go through, or how tough is it. So yield strength is the strength of wood material, and this is compared to the loads. At layers part, you can see a very quick review of the layers regarding safety or focusing on safety. So we can see the layer's name, the height of it, the decayed area ratio, the safety factor calculated for that layer, and the risk rating of the layer as well. If we select a layer, let's select this one, the details of the selected layer will appear here, and coming back to the right side of the window, well, we had image editor here, but we also have a so-called layer map, which is this. It is a very simplified image of the layer. So blue represents the good sound wood part. These are the parts which hold the load, while any other parts, even if it's a decay or just not high quality wood, it is simplified that if it was not there at all, because it does not hold the load. And the decayed area is calculated just like the area inside this black outline. And the decayed area is the percent of the decayed area regarding to the whole area inside the black lines. What else can be seen here is this red outline, and this is the direction dependence of the load. The program calculates in every 5 degrees angle if the wind is coming from that angle. And then these load values calculated, well, it is not the exact value, it is just represents the ratio. So it means that we have higher load here in this direction if the wind is coming in this direction because of the geometry. It will be higher or harder to survive for the tree, while it will be easier for the tree if it's coming maybe in this direction. So this red outline refers to the direction dependence of the load. To help to know the direction, which is the most unlucky for the tree, here is the compass in bottom right corner. You can also export this image with this icon in the top right corner, and it will be sent to the image container. Let's return to the left side of the window. Here we have the details of the selected layers, starting with the safety factor. It's very important to understand that safety factor is not a probability. It's not a chance, it is a ratio. It is a ratio between the load-bearing capacity and the estimated summarized load, wind, self-load, and the load coming from leaning if the trunk is leaning. And it's also very important to know that this safety is for trunk failure, and it is for trunk failure only. So even if you have measured at ground level, this safety refers if the trunk will break at that level. So in ArborSonic software, there is no information about the root system or the root safety. But sometimes it's very tricky because if you have a healthy tree, according to or measurements, many measurements, and measurement by our colleagues and tree assessors who we contacted in this topic, it's very common that the safety factor for the layers of the trunk and the roots safety are very close. But it is just because if the tree is healthy, it is so smart that it knows where to grow more. So if it feels weak in one area, the tree will grow more material to that area. So trunk failure and root and uprooting will be avoided. Both of them will be avoided by the tree. But please don't be misled by this information. Trunk safety and root safety should be measured independently, always, in all cases. If you are interested in root safety, you can interpret a pooling test or a dynamic test. Okay, let's returning here. We have risk rating. Risk rating depends on the safety factor's value. It is low risk if the safety factor value is above 150%. It is moderate risk between 100 and 150%, and the layer is rated as very risky, high risk if this value is under 100%. The decayed area, I have mentioned it before in this part. This is the decayed area compared to this total area of the selected layer. FPR is the average ratio of the intact wall to trunk radius. We present this information because it's still used in some standards. Tree weight above the layer, well, that's what you would guess. It is the weight of the tree above the measured layer, above this selected layer. So in this case, it's above 100 centimeters. M is the bending moment of the wind regarding that selected layer, and max stress is the maximal stress occurring at that layer, which includes the wind, the self-load, and the load from the leaning. Self-load is always calculated. The safety factor highlighted at the bottom is the weakest layer safety factor. So even if I choose another layer here at layers, like this, and these data change, image change here, this value is the same. So this is the safety factor of the weakest layer, and it will not change, and it is so important information, so even if I go up, it's still there. So this is the weakest measured layer. Under it there is a warning that the software calculates as if your trunk was tube-like. So if it has at least a little intact wall all around itself, but if there is a split, if there is a lack of material, uh, vertical split, it can change the situation significantly and reduce the safety, because in that case there is a risk of collapsing of the trunk. So always be aware of that. If there is a vertical split, this safety factor is not applicable anymore. We have one more setting affecting this step, which is the set of units. So as on sensor geometry tab and as on tomograms tab, here we can set the unit again from metric, which is the centimeters, meter per second, square meters, to the standard one, which uses inches, foot, square foot, miles per hour, and so on. So this was the last setting here on Biomechanics tab, but please let me make you remember that ArborSonic software does not have any autosave function. So when you have finished the evaluation, please save your work with save or save as. And well, if you're interested in measuring acoustic tomography, you can continue with our videos about measurement, or if you're interested in root safety, you can check our videos about dynamic test, or you can look for our videos about pulling test too. Thank you for your attention. Bye bye.